Hello viewers, Bweyogerere taking you through the story for A-level principal mathematics. And this video, we are going to go through the expected response for Senior 5 Math end of Term 1 for the year 2025. So this video is suitable for students in Senior 5 offering principal mathematics as part of their combination. So this is what we hope to upload. What is ticked means it's already available on the platform, and what is not yet ticked means will be uploaded with time. So in this video, we are going through the paper for Good Shepherd High School in Bweyogerere. So I managed to get the paper of Mengo SS, so next video will be for Mengo SS and also for Mbali SS. So if you are watching this video and in your school you did scenario-based end of term exams, I encourage you to take a picture of your paper and you send it to my WhatsApp on this number so that we can add you on the list. So King's College Budo, I've not yet got your paper. SMAC, I've not yet got your paper, and many others. So if you're not seeing yourself on the list, please, I encourage you to send your paper for the school you did. But if some of you are funny, you send the paper and you cut off the headed part which has the name of the school. I'm interested in the name of the school so that when I'm uploading, I can know that this is a paper for such and such a school. So these are the books we recommend for A-level. So there are two books for math, Math Part 1 and Math Part 2. What you should be keen of is this black circle having the word based on revised A-level syllabus. For physics too, there are two books, paper 1 and paper 2. Then subsidiary math is only one book, and for the rest of O-level, they have O-level item bank containing items, scenario-based items for physics and mathematics, and based on topic by topic and also element of construct. Then also the physics book for Senior 3 and Senior 4 work. So for any of the copies, contact me on this contact. So today we shall go with this paper. This one had two sections. It has a section of applied math, which involves statistics based on your curriculum, because term 1, what is on the syllabus is descriptive statistics, and also some mechanics based on the school where you are. So applied math, and section B was pure math. So the papers to be done, the ruling is not yet out. So some schools do one paper, others do two papers, so that shouldn't confuse you. As long as the assessment is scenario based, then you are good to go. So item 1 says, in a certain town, there is a section of the road where many accidents occur, and the residents believe it is due to overspeeding. So they have requested the authorities to build humps along that section. The chairperson of the roads committee has decided to do some research. So a checkpoint has been put at that section to measure the speed of 50 vehicles passing that point. They will put humps if the research shows that the majority of the vehicles passing that point use a speed greater than the speed limit. The road sign shows a speed limit of 55 kilometers per hour. For that section, the results for the 50 vehicles are shown in the table below. So these are the speeds and the corresponding number of vehicles with that speed. The task is assist the chairperson to determine part A, the average speed at which the vehicles pass the checkpoint, and part B, the standard deviation of the speed at which the vehicles pass the checkpoint, and part C, present a graphical analysis to guide the committee's choice of implementing traffic calming measures. So So here, this is under grouped data. Like I told you, for this new syllabus, we don't cover ungrouped data. So if at your school you covered ungrouped data, then you can just ignore it because we start from right away from grouped data. So this is grouped data, and the first thing to do when you're answering such questions is to tabulate. In other words, to draw a frequency distribution table. That table must have a title. So that will be our x. Then you can come and tabulate. Speed. So what we use to put as classes now, we use what is in the question. So speed, we shall give what is in there in the question. The next is cumulative frequency. So you are supposed to realize that that was cumulative frequency and not frequency. Reason, if you look at this ends at 50. And they also told us in the scenario that the vehicles in play are 50. So total number of vehicles should be 50. And this is 50, meaning that these are cumulative frequency values. Then now frequency we subtract. So 13 minus, so first of all we shall write 5, then 13 minus 5, 8, 20 minus 13, 7, 29 minus 20, 35 minus 29, 40 minus 35, 44 minus 40, 50 minus 44. So when you add all these ones, you'll be able to get the 50, which is in the scenario. Then shall need x. X means you add and divide by 2. This divided by 2 is that the 30 plus 40 divided by 2, 40 plus 50 divided by 2, 50 plus 60 divided by 2, 60 plus 70 divided by 2, 70 plus 80 divided by 2, 80 plus 90 divided by 2, 90 plus 100 divided by 2. Then we can multiply now because we have to get the mean. So 5 times 25, 8 times 35, 7 times 45, 9 times 55, 6 times 65, 5 times 75, 4 times 85, 6 times 95. So then you add everything here to come up with this. The next is fx squared. So for fx squared, you realize that when you multiply this with this, you get fx squared. So those are the columns I'm going to multiply. So 25 times 125, 35 times 280, 45 times 315, 55 times 495, 65 times 390, 75 times 375, 85 times 340, 95 times 570. So next is to add all these values and we come up with this. So now that we have tabulated, we can now start answering the tasks. The first one is assist the chairperson to determine the average speed at which the vehicles pass the checkpoint. So the formulas are available in the logbook. So code the formula correctly, substitute and get the output. But I told you for your syllabus, you need a response. In other words, you have to communicate what you are calculating. So at the end of it, we need to see this word. The average speed at which the vehicles pass the checkpoint is this, which has been got from this calculation. Then part B, the standard deviation of the speed at which vehicles pass the checkpoint. So you have to code the formula, then you substitute fx squared, summation f, fx, then you get the output. Then you need a response, standard deviation of the speed at which vehicles pass the checkpoint is this. So that was task B. Then task C, it says, present a graphical analysis to guide the committee's choice of implementing traffic calming measures. Remember, there was a condition. One, they said they will put humps if the research shows that the majority is mod. Majority of the vehicles passing that point use a speed greater than the speed limit, which is this. So our work is to find the mod. When the mod is bigger than 55, we say they have to put humps. When the mod is smaller than 55, we say they don't need to put the humps. So basically that is it. So shall come here and get our graph paper. We draw the axes, horizontal and vertical, then get a scale for the horizontal axis, whereby you must start with the lower class boundary and label the axis. Do the same for the vertical. Get the scale and label the axis. Then you shall need a title of your graph. After that, next is to plot. So you shall plot bars from 20 to 30, they will correspond to a frequency of 5. From 30 to 40 correspond to a frequency of 8. From 40 to 50 correspond to a frequency of 7. 50 to 60 correspond to a frequency of 9. 60 to 70 correspond to a frequency of 6. 70 to 80 correspond to a frequency of 5. 80 to 90 correspond to a frequency of 4. Then 90 to 100 correspond to a frequency of 6. Then next is to get the mod. Remember, the mod, we look at the highest frequency, then we draw a line, dotted line, that then connecting this to this, and then the intersection, we drop a perpendicular. So that dotted line, then at the intersection, we draw a vertical line to meet the horizontal axis, and we read off that value. So we can now give a response that the majority of the vehicles passing the checkpoint use a speed of 54 kilometers per hour, which is less than the speed limit, so the committee will not need to put the humps. And that is what they wanted. Then that item 2, still on group data, it says, due to poor performance in mathematics that was observed among the learners in pre-registration exams, the school administration, through academic board, came up with strategies to improve the learners' performance. Some of the strategies are that a prize is given to learners scoring above 78%, and the remedial exam be given to learners scoring below 56%. Mathematics examination was given to S.5 learners, and marks were obtained as below. Then task part A, using an appropriate statistical graph, help the administration to determine the number of students to be awarded prizes and those who will be given remedial exams. So part B, determine the average mark scored by the students and the standard deviation of the marks. So like I said, we shall still tabulate. The first thing to do is to get a title for your frequency distribution table. Then you can tabulate. We shall begin with the classes which are now marks. Then next will be the frequency density, which is given. Remember, frequency density is frequency over class width. Frequency over class width. So since class width is got from class boundaries, next column will be class boundaries, which is that. I think by now you're aware of how class boundaries are got. Then from there we know that class width is equal to the difference between the upper and lower class boundaries. So this minus this, 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 this minus this. So now that I have class width and I have frequency density, I can get frequency by multiplying frequency density times class width. I'll end up with frequency. So multiply this with this, 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 and this with this. So now I've got frequency, I will need the total. So next is to get the mid value, which is x. So this plus this divided by 2, 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 this plus this divided by 2. Then you can now get fx. This times this, 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 this times that. Out of which you shall get the total, which is summation of fx. Then you also need fx squared. So this times this, 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 this times that. Then you also get the total of all this, which is summation of fx squared. Then you also need to measure frequency. So this plus this, 16 plus this, 24 plus this, 33 plus 5, 38 plus 2, and the result. So now that you are done with tabulating, we can now start answering the questions. So it is advisable you first tabulate before you even start answering the questions. So part A said, using an appropriate statistical graph, help the administration to determine the number of students to be awarded prizes and those who will be given remedial exams. So let's go back to the scenario and we see the condition which was given. The condition was that a learner who scores above 75 will get a prize, and the one who scores below 56 will get a remedial. So you need to get the number of learners who are above 55, 78, and also those who are below 56. So you shall get a graph paper, draw the axis, horizontal axis and vertical axis. Use intervals of 2 to centimeters on the horizontal and get a grid scale starting from the lower class boundary. Label the axis. Do the same for the vertical. Use intervals of 2 to centimeters and get an appropriate scale so that all the values can fit. Label the axis. Then shall need a title for the graph, after which we shall start plotting. We plot geometric frequency against upper class boundary. So we're interested in these values together with this. So 54.5 corresponds to 3. So we shall come and locate 3. 60.5 corresponds to 16. So come and locate. 68.5 corresponds to 24. Then 74.5 corresponds to 33. 79.5 corresponds to 38. 84.5 corresponds to 40. Then shall draw a reasonably smooth curve through these values, but that curve must start from the origin. It shouldn't be left hanging. So now that we have drawn the curve, we can now use it to estimate. In the estimation, let's go back to the task. They said use an appropriate statistical graph. Help the administration to determine the number of students to be awarded prizes and those who will be given a remedial. Remember, to be awarded, you must get above 78, and to get a remedial, you must get below 56. So to get those who are above 78, we first come and look for 78 on the horizontal axis. Remember, 78 is the one which has the max. Horizontal axis is the one which has the max. So we shall look for 78 and take a vertical line up to meet the curve. Where they intersect, you take a horizontal line to meet the vertical axis. Then read off that value, it will be 36.75. Now that is the number of students who got below 78. So those who have got above 78 are the x's. So 40 minus f78 will give you those who got above 78. So 40 minus this gives you this, which rounds off to 3. For those who got a remedial, shall look for 56. Then the intersection here, take a horizontal line to meet this and read off that value. Then you can come and see the number of students below 56 is this. Then you round off to a whole number. So here it is okay, because here some students find challenges. They ask themselves, should we round off or shouldn't? So that is debatable. So what we do, we give both options. So a student who writes 4 is okay when you truncate. Then a student who writes 5, it is okay because you have rounded off. So both approaches are okay. So a student who truncates and a student who rounds off, they will both get the answer. So you have said there are 3 students who will be awarded a prize and 5 students who will be given a remedial. I think you see I said except 4. That is for the case of someone who truncated. The next task, that is part B. Let me first see. Part B. They said determine the average mark scored by the students and the standard deviation of the marks. So mean summation fx over f, substitute and get the answer. Give a response of what you are calculating. Then also standard deviation, quote the formula correctly, substitute and get the answer. Then give a response what you are calculating. And that is all. So now we shall go to item 3. Item 3 says, a teacher gave a mathematics test, recorded the marks out of 50 for 40 students. The teacher chooses 35 as the assumed mean for easier calculations. He wants to allow students who scored above the middle mark to continue with the subject on merit. Advise the last 10% of the students who scored below the middle mark to change the subject, and the rest of the students who scored below the middle mark were given the last chance. The students scored as follows. So I have those scores. Then here they said task using a class width of 5. The first class being this. Part A, help the teacher to determine the mean mark and the standard deviation of the marks scored by the students. Then part B, using an appropriate graph, determine the number of students who will be advised to change subject and those who are to continue with the subject on merit. So the first thing to do is to tabulate. Shall get a title for the table, frequency distribution table. Then you can draw a table. First, we shall write the classes. Those are the classes. Then we shall start doing tallying. So from 10 to 14, so 10 to 14 it is only 1. Then 15 to 19 there's 1, 2, 3, 4. That is 4. So I shall write here 1. Here there is 4. Sorry, here there is 4. Then 20 to 24. 20 to 24 we have 4. 25 to 29 we have 5. So I shall write here it is 4. Here it's 5. Then 30 to 34 it was 5. 35 to 39 it is 8. So we shall write here 5, here 8. Then 40 to 44 it is 8. So 1, 2, 3, 4, yeah, it is 8. Then 45 to 49 it is 5. So I have 8 here and 5 there. So those are the tallies we are going to put. So the first one it was 1, next was 4, next was 4, next was 5, 5, 8, 8, 5. So I can now write the frequencies 1, 4, 4, 5, 5, 8, 8, 5. Then get the total, which is 40. They wanted mean, so we need to get the values of x. So this plus this over 2, 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 and this plus this over 2. Okay. The next will be D because they gave us a working mean. So working mean of 35. So we shall say this minus 35, 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 and this minus 35. Then we shall need now FD. So FD will be this times this, maintain the negatives, this times this, 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 this times that. Then shall need the total of all this. Total will be negative 70. Then for standard deviation, we shall need FD squared. So this times this, 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 and this times that. So still add everything here, you'll come up with this. So next is geometric frequency. First write this one here. Then 1 plus 4 is 5. 5 plus 4 is 9. 9 plus 4, 14. 14 plus 5, 19. 19 plus 8, 27. 27 plus 8, 35. 35 plus 8 plus 5, 40. The next is class boundaries. Class boundaries for the first one. So here add 0.5, and for the lower class limits you subtract 0.5 to get the class boundaries. So you shall come up with these class boundaries. Okay, so after drawing the table, we can now answer the question. The first one was mean. Using assumed mean, it was that. Then response. Next was standard deviation, so you quote the formula, substitute, and get the answer. Then give a response. So now we shall go to part B. Part B says, using an appropriate graph, determine the number of students who will be advised to change the subject, and those who are to continue with the subject on merit. Remember here they told us something, that 1, the paper was marked out of 50. Okay, then they said he wants to allow students who scored above the middle mark to continue with the subject on merit, those who scored 25 and above. Then advise the last 10% of the students who scored below the middle mark to change the subject, and the rest of the students who are below the middle mark will be given a last chance. So shall come here and say, get the graph paper, draw the axes, horizontal and vertical. Put intervals of 2 to 3 meters on the horizontal and get an appropriate scale starting from the lower class boundary. And label the axis. Do the same for the vertical, intervals of 2 to 10 meters. And then get an appropriate scale to cover the whole cumulative frequency. Then get a title for your graph. And then you can start plotting cumulative frequency against upper class boundaries. So 14.5 corresponds to 1, so 14.5. 19.5 corresponds to 5. 24.5 corresponds to 9. 29.5 corresponds to 14. 34.5 corresponds to 19. 39.5 corresponds to 27. 44.5 corresponds to 35. 49.5 corresponds to 40. Then we shall draw a reasonably smooth curve starting from the origin, starting from the lower class boundary and 0. So lower class boundary will correspond to 0 here. Then middle mark is 25, so I'll come on the horizontal axis and look for 25, take a vertical line to meet the line, and take a horizontal line to meet the vertical axis, and read off that value. So that means that number of students below the middle mark are 9. When they're 9, they told us the number of students to change subject are 10% of this 9, which will be 1 student. The number of students above the middle mark will be 40 minus this, which will give you 31. So only 1 student will be advised to change the subject, and 31 students are to continue with the subject on merit. So that was section A. Now we shall go to section B, which is for pure mathematics. Item 4 says, in a certain chemical processing company, product X is formed by combining reactions P, Q, and R according to the reaction equations below. So it's an equation P, small p, capital P, plus small q, capital Q, plus small r, capital R, equal to X. That's the equation where P, Q, R are different ratios that vary with time. The company produces product X in shifts, morning, evening, and night shifts. The table below shows how different shifts combine reactants to produce P, Q, and R, reactants P, Q, and R to produce X on Friday. So in the morning, they mix in the ratio of 3 to 2 to 1 to produce this of X. So that means that if I get 2 times this, 3 times this times this, it gives me 10. Then on the evening, same story, and at night. So this topic is under simultaneous equation. So the question says, your aunt is working with a company and would like to know the quantities of each reactant, the quantities. So this one, the quantities of each reactant used, and she has approached you. So quantities is quantities, you edit it. So they want to know the P, Q, and R. So as a student of mathematics, use your knowledge to help your aunt to know the amount of P, Q, and R that were used on Friday. So equation 1, equation 2, and equation 3. So next is to solve them simultaneously. So when I multiply equation 1 by 3 and subtract and say minus equation 2, I come up with this. Then also equation 1 times 2 minus 3, it gives me equation 5. Now I've eliminated R, I can now solve 4 and 5 simultaneously to remain with only one unknown, which can be got. Then from equation 5, I can come up with the value of P as 2, and from equation 1, I can come up with the value of R as that. So that would be the answer. Though the English didn't come out well, but basically what they wanted is for you to solve simultaneously. So now we shall go to item 5. Item 5 says, the Uganda National Roads Authority is studying traffic patterns on the Kampala-Jinja Highway. They have developed a mathematical model to predict traffic density at different times of the day. The traffic density function dx at time x hours is given by this. Task: as a traffic engineer, you need to analyze this model and present the function as a sum of partial fractions. So they want you to, in short, they want you to express this in form of partial fractions. The good thing, the factors are distinct. So this one will be split into a over x plus 3, b over x minus 2. And do you see this? The denominator is quadratic, meaning the numerator should be linear. In the first two, the denominator was linear, meaning the numerator should be a constant. But here the denominator is a quadratic, so the numerator should be linear. I would have said cx plus d, but d is already used in the question, so I have to skip it and go to e. Then I can equate numerator, so you should realize there is an equivalent sign here. When I equate the numerator, it means that this side I have to get LCM. So getting LCM means LCM divided by this, you remain with this 2 for A. For B, LCM divided by this, you remain with this 2. For this, LCM divided by this, you remain with this 2. Then I can start putting different values. So putting x equal to 2, it means that this whole term will become 0 and this whole term will become 0. So I'm going to remain with b, then 2 plus 3, which is 5, and 4 plus 1, which is 5. This side I'll remain with 8 minus 32 minus 1. So in the end, I'll come up with the value of b as -1. Then putting x equal to -3, the whole of this will cancel and become 0, and the whole of this will become 0. So I remain with this part. Therefore, this a here, -3 minus 2 is -5. 9 plus 1 is 10. Then this side we shall get here -27 minus 72 minus 1. So you end up with the value of a as 2. Then putting x equal to 0, there nothing will go away. Okay, at least this will go away, cx, but the rest will remain. So I'll come up with that. Simplify, then substitute for a and b. Simplify, then get the value of e. So what I'm left with is the value of c. So I should put another value. If I put x equal to 1, I'll come up with that. Simplify, now substitute for a, b, and e. You remain with that. Then you can get the value of c as 0. After which you can rewrite the required partial fraction, and that is what they wanted. Then you have to give a response. That was item 5. Then item 6 says, the Kampala City Council is planning to construct 2 new roads in the city to ease traffic congestion. Before construction begins, engineers need to determine the exact alignment of these roads to ensure smooth traffic flow and proper connectivity. The first proposed road will pass through the coordinate points of Kasubi and Chireka, while the second road will pass through the coordinate points of Banda and Chambogo. On a map of Kampala, to ensure roads are well positioned that don't create a sharp turn or difficult intersections, engineers must calculate the inclination angle between them. But little do they know that border riders are already planning their shortcuts. Task: compute the road equations, point of intersection, if so, and the inclination angle to ensure a safe and efficient road network. So the question is all about getting equations of straight lines given 2 points. So for the road through Kasui and Chireka, we shall equate gradients, simplify, cross-multiply, and get the equation of that road. Do the same for the second road through Banda and Chambogo, equate gradients, simplify, cross-multiply, and collect like terms. So those are the two roads. We can give a response that the equation of the road through Kasui and Chireka is that, while that through Banda and Chambogo is that. Then next they will need the intersection. Point of intersection, it means that the two roads have equal values of x and y. So equate the equations, simply collect like terms, and get the value of x. Now from end of the equation of the straight line got, you will substitute for x and get the value of y. Then you can get a response. But they also wanted the angle between these two lines. Remember, the formula is there in the logbook. Once you know the gradients, you can code the formula for the angle between two lines from the logbook, and then you substitute. Use the calculator to get the angle, and that is it. So that is what they wanted. Item 7 says, a renewable energy company is installing solar panels on a building in Tororo district. To maximize energy collection, they need to determine optimal installation angles based on buildings orientations and sun's position. The company engineers found out that the solar panels had the following equations: panel A, panel B, and panel C. Task: as a mathematics student, prove that the above equations for each panel is related. So they want you to prove that this left-hand side is equal to right-hand side. For panel A, the same for panel B, and the same for panel C. So let's start the proof. So for panel A, we shall begin from left-hand side. Left-hand side, this is what we are given. So what we are going to do, we are going to introduce an innocent expression of 1 plus sine theta on both sides. 1 plus sine theta, 1 plus sine theta. When you do that, you realize that this and this becomes this, and this becomes different with 2 squares, which is here. But from Pythagoras identity, 1 minus sine squared theta is the same as cos squared theta. Now both have a square, meaning that you can put the square outside the bracket. Then you split the numerator, 1 over cos plus sine theta over cos theta. 1 over cos is sec theta, and sine theta over cos theta is tan theta. And that's what they wanted. For panel B, left-hand side is that. Change, we know that sec is 1 over cos, cosec is 1 over sine, and cot is cos over sine. So that means that when I simplify, realize that this and this is squared, so I'll come up with this. Get the LCM. LCM is cos theta sine squared theta. So that divided by cos theta, you remain with sine squared theta times 1 to give you this. Then this LCM divided by sine squared theta, you remain with cos theta, then cos theta times cos theta to give you cos squared theta. Now still from Pythagoras identity, sine squared theta plus cos squared theta is equal to 1. Then from there it means that 1 over cos is sec, and 1 over sine squared is cosec squared. And that's what they wanted. For panel C, left-hand side is that. So change, cot is the same as cos over sine, tan is sine over cos, cot is cos over sine, tan is sine over cos. Then from there, you get LCM for each numerator alone, get LCM to come up with that. This one combined to one quotient to come up with this. Then from there, realize that this, they can't cancel. I thought they can cancel, but they can't cancel. However, the ones up can cancel this one and this one. They can cancel out, so remain with 1 over this and 1 over that. Simplifying means this goes up to become this. Then from there, cos alpha over sine alpha, cos alpha over sine alpha is cot alpha. Then sine beta over cos beta is tan beta, and that is what they wanted. Then you can give a response for your answer.